Inches, March 2026. Scientists at the Royal Netherlands Institute for Sea Research confirmed that 27 million tons of invisible plastic particles are floating inches the North Atlantic alone, more than all the visible ocean plastic on Earth combined. Visual. Type location. Pin location. North Atlantic Ocean. Coordinates 45, 0, 30, 0, duration. For decades, researchers have been haunted by a paradox they couldn't solve. Humanity has produced billions of tons of plastic, yet only a tiny fraction could be accounted for inches the oceans. The rest had simply vanished. And the answer to where it went? It's already inside you. It's already inside your children. Scientists have now found these particles lodged inches human brain tissue. But before we get to that, listen carefully to what one of the lead researchers told reporters the moment the data came inches, because his exact words were, quote, "The nanoplastics that are there can never be cleaned up." To understand why this discovery is sending shockwaves through the scientific community, we have to go back to a problem that has frustrated oceanographers for over 20 years. It's called the missing plastic paradox. Since the 1950s, humanity has produced an almost incomprehensible amount of plastic. Every plastic bottle, every shopping bag, every fishing net, every fragment of packaging. Much of it eventually finds its way into rivers, and from rivers, into the sea. Scientists have spent decades measuring how much plastic enters the ocean each year. They've mapped the great garbage patches. They've trawled the surface waters. They've counted, weighed, and modeled. And every time they did the math, the numbers didn't add up. Only about 1% of the plastic believed to be inches the ocean could actually be found floating on the surface or washed up on beaches. The other 99%? Gone, invisible, unaccounted for. Visual, type, try, data glitch value, SAWI, 99, unit. Percent unaccounted for, context. Of all ocean plastic ever recorded, duration. Some researchers theorized it had sunk to the seafloor. Others believed marine life was consuming it. A few suggested it was breaking down into pieces too small to see, but no one could prove it, and no one could measure it. Until a master's student named Sophie Hietbrink boarded a research vessel and spent 4 weeks at sea. Visual type radar sweep location. North Atlantic, Azores to European continental shelf. Duration. Inches the summer of 2025. Sophie Hietbrink, a graduate student at Utrecht University, joined a scientific expedition aboard the Dutch research vessel RV Pelagia. The mission was simple inches concept, but extraordinarily difficult inches practice. Collect water samples from 12 different locations spanning from the Azores all the way to the European continental shelf. For 4 weeks, she worked inches shifts, hauling sample containers from the deck, filtering ocean water through specialized membranes, and preparing them for laboratory analysis. The team wasn't looking for plastic bottles or microbeads. They were hunting something far smaller, particles measured inches billionths of a meter. Particles so tiny that 1,000 of them lined up would still be thinner than a single human hair. These are nanoplastics. And until this expedition, no one had ever been able to estimate how many of them were actually out there. When the samples returned to the laboratory Inches, the Netherlands, the team used advanced mass spectrometry to identify and quantify the polymers Inches the water. What they found stunned them. The vast majority of the particles fell into 3 categories: polyethylene terephthalate, the plastic used Inches drink bottles and clothing fibers; polystyrene, the foam Inches takeaway containers and packaging; and polyvinyl chloride, PVC, found Inches pipes, flooring, and countless industrial products. Visual, type terminals readout lines. Polymer analysis, RV Pelagia. Samples PET, polyethylene terephthalate. Detected, polystyrene. Detected, PVC, polyvinyl chloride. Detected. Status, ubiquitous contamination confirmed. Duration. These weren't exotic chemicals, they were the materials of everyday life, and they were everywhere Inches the water. Data, type stat value, 27 million unit Schadens context, Nanoplastics floating inches North Atlantic alone, dramatics are true. When the researchers scaled their measurements up across the entire North Atlantic, the final number was almost too large to comprehend. 27 million tons. That's roughly the weight of 2,700 Eiffel Towers, suspended invisibly inches the water of a single ocean basin. Visual type conspiracy board nodes. North Atlantic 27 megatons nanoplastic, human brain tissue. Particles confirmed, peat bottles chew primary source. Polystyrene, foam primary source. PVC products primary source, duration. And here's the part that changes everything. This amount of nanoplastic, inches just the North Atlantic, exceeds the total mass of all larger microplastics and visible plastic debris, floating inches every ocean on Earth combined. The missing plastic wasn't missing at all. It had simply broken down into pieces too small for anyone to see. But how did all this plastic get there? And why are the particles so small? The study published Inches Nature, Volume 643, identified 3 primary pathways. The first is the breakdown of larger plastic objects by sunlight. Ultraviolet radiation, combined with wave action and salt, slowly shatters bottles and bags into fragments. Fragments that keep fragmenting, year after year, decade after decade, until they reach the nanoscale. The second pathway is river runoff. Every river that flows into the Atlantic carries with it the plastic waste of every city, factory, and landfill upstream. Data, type, staggering, comparison label, a visible ocean plastic worldwide, label be invisible, nanoplastic inches North Atlantic alone. And the third pathway is the one most people have never considered: atmospheric transport. Nanoplastics are so light that they can be lifted into the air, carried thousands of kilometers by wind, and then deposited back onto the ocean's surface, either through rain or simply by falling out of the sky as dry dust. Inches, other words, plastic pollution is no longer just a water problem. It's an air problem. It's a weather problem. It is, quite literally, falling on us from above. This brings us to the most disturbing part of the story. Lead researcher Helge Niemann, a professor of geochemistry, told reporters that nanoplastics have already been detected inches human brain tissue. Let that sentence land for a moment. Not inches our drinking water, not inches our food, inches our brains. Because these particles are so small, smaller than a single bacterium, they can cross biological barriers that larger microplastics cannot. They can pass through the gut lining. They can enter the bloodstream, and recent studies suggest they can cross the blood-brain barrier, the body's most protected defense system, designed specifically to keep foreign substances out of our central nervous system. What they do once they're inside, no one fully knows. That's exactly why, Inches June 2025, Niemann was awarded a €5 million grant to investigate the long-term biological impacts of nanoplastic exposure. The questions researchers are asking now are the kind of questions that keep neurologists awake at night. Do nanoplastics trigger inflammation in brain tissue? Do they accelerate neurodegenerative diseases? Do they affect cognitive development in children? Do they accumulate over a lifetime, or does the body eventually clear them? We don't know. We're only just beginning to ask. And now we come to the warning the scientific team delivered alongside their findings. A warning that has been called the most chilling sentence inches environmental research this decade. The nanoplastics that are already there can never be cleaned up. Think about that. We can pick up plastic bottles from beaches. We can deploy nets to skim the great garbage patches. We can filter rivers and improve waste management. But once plastic is broken down into particles measured inches billionths of a meter, it becomes physically impossible to remove from the ocean. You cannot filter it without filtering out the plankton and microorganisms that form the base of the marine food web. You cannot extract it without destroying the very ecosystem you're trying to save. The 27 million tons inches the North Atlantic are there forever, and every plastic bottle thrown away today will, given enough time, eventually become more of the same. This is why the researchers emphasize that prevention is the only solution, not cleanup, not technology. Prevention, reducing plastic production at the source, replacing plastic packaging with biodegradable alternatives, capturing plastic waste before it ever reaches a river. Because every choice we make about plastic today is inches of very real sense, a choice we are making for thousands of years to come. Nanoplastics, unlike organic pollutants, do not biodegrade on any timescale that matters to human civilization. So here is where we leave you, with a mystery that has been solved, and a far greater mystery just beginning to unfold. We finally know where the missing plastic went. It didn't disappear. It dissolved into something smaller, something invisible, something that now circulates through our oceans, our atmosphere, our rain, our food, our blood, and our brains. The scientists who made this discovery aren't asking whether nanoplastics are harming us. They're asking how badly and how soon we'll find out. Here's the question I want to leave you with. If 27 million tons of nanoplastic inches just one ocean basin can never be removed, and if every plastic item produced today will eventually join it, what do you think the world looks like inches 50 years? Inches 100? Are we already past a point of no return that we don't even recognize yet? Tell me what you think inches the comments. I read every single one. And if you want more stories like this, the discoveries hiding inches plain sight, the things scientists are only now beginning to understand, subscribe to the channel and turn on notifications. Because the next mystery is already being uncovered, and you don't want to find out about it too late.